Let's start with section 4.2, Rolle's theorem. So you have to look to the graph. What we're gonna do with these two conditions. In fact, in the future, when you're going to use the Rolle theorems, you have to prove 2 points. With these examples, they're gonna give you f is what? Continuous. You have to prove that f is continuous on the closed interval AB and differentiable on the open interval AB. First of all, you have to prove these two conditions. I'm not talking about now. In the future, when you're using the Rolle's theorem, because you're going to use it, you have to prove f is continuous on the closed interval AB and differentiable on the open interval AB. If these two conditions satisfy, then we can use Rolle theorem with to prove that FA equal FB. That means you're gonna plug in FA should be equal F to the B and equal any number. Okay? So now if this condition also satisfied, that means there exists a number X. So here is A and here is B. And this point it should be here. If FA equal FB and F is continuous between A and B, differentiable between A and B, and FA equal FB, then there exists a number here between A and B. The derivative for the function with the number X equal what?
0.
0. That's called Rolle theorem. You can check that when we do an example. Well, maybe I did that much higher. Let's check this example. Yeah, he will take it. So first of all, find two x-intercepts. Because we don't have x-intercept, we don't have the interval, so we're gonna say, okay, our interval could be the x-intercept, and they're telling you here, find two x-intercepts of the function to show that the derivative of x equal 0. At some points where between the two x-intercepts, that means our interval is the x-intercept. So this is the information I need. Here is the function. I'm just gonna write down the function, which is f of x equal x squared minus 17x minus 18. So our goal is to find the x-intercepts. Then I need to find x between the x-intercept, satisfy this condition. The derivative equal 0. So write down this information because I'm going to go to the next board. Intercept. How are we going to find x-intercept?
Equal it to 0?
Every time when you need to find x-intercept, so don't forget these notes. When you need to find x-intercept, you're gonna let y equal 0. Where is y? F of x. So 0 is going to be equal x squared minus 17x minus 18. Now what's the next step? What's the next step? Until now, we're not using the Rolle's theorem. Now I need to find the x-intercept. I'm gonna find the x-intercept. Now what I'm gonna do here? Yes, like we're gonna factor it because it's quadratic. So I'm gonna say, okay, 0 equal 2 parentheses 1x, 18. And here is 1. The sign is going to be negative, positive. Okay, just factor in. Then use the zero factor property. I'm going to say 0 equal x minus 18. Solve this one. 18 is going to be equal to x. So the first x-intercept is 18 and now 0 is going to be equal x plus 1. That means -1 is going to be equal x. So here is our second x-intercept, which is -1 and 0. So now I have the interval, which is, how are we going to have the interval? That means A, B is equal to what? They're telling you AB is the x-intercept. So it's -1 and 18. So this is the interval A, which is -1 and 18. Now next is that we're going to use the Rolle's theorem. I need to find a value between -1 and 18. The derivative for this value is going to be equal 0. Now, I need to satisfy which condition? Satisfy the condition it says f of A equal f of B and equal, no. That's what we need to satisfy. That's what we need to satisfy f to the -1 is equal f to the 18. Let's check that. F to the -1 equal what? Plug in -1 where? So -1 squared, that is 17 times -1 minus 18. So equal 1. 1 plus 17 okay, minus 18 is 0. And now I'm gonna go for the 18. F to the 18 is going to be 18 squared minus 17 times 18 minus 18. So it's going to be 18 squared, 324 minus 306 minus 18. Is that right? Which is equal 824. So now the condition for the Rolle's theorem is satisfied. We found out that means f to the -1 equal f to the 18, which is equal to 0. That means there is an x between A and B. So here is A, which is equal -1, and here is B, which is equal 18. There is x between these two numbers. The derivative for this x equal 0. Then I'm going to find the derivative for the x, which is equal. Here is x, which is 2x minus 17. Now I need to find the x. I need to find the x. How are we going to find the x? The condition says what? The derivative of x equal what? 0. That means here is the derivative, right? So 0 equal 2x minus 17. That's mean, can we solve this one? Move the 17, so 17 equal 2x. Divide by 2. So x equal what? 17 over 2. So we found a value of x and check the value of x. 17 divided by 2 is what? Almost what? The result is between -1 and 18. That means there is a value of x, which is 17 over 2, between A and B, the derivative for this value is going to be equal 0. You got it? Just easy steps, you have to take this example. You do the same thing. Find two x-intercepts of the function to show that at prime to the x equals 0 at the same point between the x-intercept. So now our function is f of x equal x square root of x plus 5. How are we gonna find the x-intercept? Don't overthinking.
It's equal to 0 and then the square root of x plus 5, which is 0.
So to find the x-intercept, we're gonna let y equal 0, which is the same thing, f of x equals 0. That's how we're gonna find the x-intercept. That means this part equals 0 equal x square root x plus 5. Now do not overthink it. It's already factored and written in the way I want. This is multiplication. So that means our x-intercept 0 equal x.
-5.
And here is going to be, here is our first x-intercept. And from this side, 0 equal x plus 5. Square both sides, x plus 5. That means x is going to be equal -5. So -5 and 0. So now we have the interval, which is always, here's our interval. From -5 to 0. And I need to find x between these two numbers. The derivative of this x equal 0. So I'm gonna write down the function. Now I need to find the x between these two numbers such that what? The derivative of this one equals 0. So I'm going to write down the function, which is f of x equals x square root x plus 5. And we need to find the derivative. So the derivative is going to be what? I'm gonna write down f of x equal. Can I do that? Now the derivative is going to be what? The first one times the derivative of the second one, the product rule, which is half x plus 5 to the -half times the derivative of inside, which is 1, plus the second one times the derivative of the first one, which is, what am I gonna do? Then I write this one again, which is here is that x over 2 square root of x plus 5 plus this one is that square root of x plus 5. So now we need to find the value of x, because the value of x when you solve it is going to be, which is the number between -5 and 0. That means the derivative is going to be equal 0. There is x over 2 square root of x plus 5 plus square root of x plus 5. Now what's the next step? So next step.
Least common denominator.
So that's me. This is over 1. And to find the least common denominator, we're going to multiply by 2 square root of x plus 5. Here times 2 square root of x plus 5. So this side, we're gonna keep it the same. 0 equal x over 2 square root of x plus 5 plus. On the other side, the root times the root is going to be 2. Here is the 2, and here is x plus 5. And everything divided by 2 square root of x plus 5. Now, can I add these together? So it'll be x plus 2, x plus 5, and everything divided by 2 square root x plus 5. Can I cancel the 2 with the 2? Can I cancel the 2 with the 2? No. No. Okay. That was the next step. What's the next step?
I thought the first step was to make sure that -5 and 0 were,
Oh, we didn't check that.
no, we didn't.
Yes, we have to check that. That's good. We have to check. I'm sure it's going to be equal.
That was my question for you.
Yes, you have
It's
to.
gonna be -5.
-5, you know, should check equal to this one. You have to check that so you can approve the Rolle's theorem. Okay? So I'm sure it's going to be equal. So check that. So now what's the next step here?
You're trying to find x, right?
We'll go. How I'm gonna cancel if I have rational
Multiply.
By-
Both sides.
by this number here. So multiply everything by 2 x plus 5, which is gonna cancel this one with this one, and 0 times by 2 x squared plus 5 is going to be 0. So the left is going to be 0 equal x plus 2x plus 5. Distribute here. 0 is going to be equal x plus 2x plus then 3x -10, it's going to be equal 3x divided by 3, x is going to be equal, which is between 0, -5 and 0. But good, you have to check this one. So to prove that I can use Rolle theorem, okay? You can say, okay, I'm gonna use Rolle theorem. Because Rolle theorem is to find all the x value between the intervals, between A and B. Then I need to satisfy what? F is continuous on the closed interval. F is differentiable on the open interval. And the third condition is what?
FA equals.
Well, F of B. So, because I'm going to use the Rolle theorem, so I need to satisfy these 3 conditions. So, see here, F is continuous. F is continuous on the interval AB. Go back to the beginning. When the function is not continuous, when you have asymptote, and when you have what? Whole, okay? Do we have asymptote with this one? When we have asymptote, which is the vertical asymptote. When we have rational, when we have function like this, like x plus 4 over x minus 3. We have asymptote here. Here is the vertical asymptote. So when we have asymptote, we're gonna check the function is the asymptote between the interval A and B. We're gonna check that. If yes, that means F is not continuous. That's why I can't use the Rolle theorem. Like if our function like this, check the vertical asymptote x equal 3. Is it 3 between the interval? Check it. 3 is between the interval. No, the 3 is here. So I can use Rolle theorem here. Because we need all, just focus on the interval. Now, if f is continuous, that means f is differentiable. So differentiable on the same interval. So the first two conditions, you can say, okay, f is continuous on the closed interval -2 and 2. And f is differentiable on the open interval. Now, the third condition, we need to prove f to the -2 equal f to the 2. So we can use Rolle theorem. Now, f to the -2 equal, plug in -2 here. So -2 to the power 4 minus 2 times -2 square, which is equal 16 minus 2 times 4. And then 16 minus 8 is going to be 8. Now I need to find what f to the 2, which is equal 2 to the power 4 minus 2 times 2 square. It's going to be the same thing, 16 minus 2 times 4, 16 minus 8, which is equal 8. That's mean f to the -2 equal f to the 2 and equal 8. So now I can use the Rolle's theorem. By using the Rolle's theorem, what I'm gonna do? Just find the derivative to the function, which is f prime to the x equal 4x cubed minus 4x. The derivative equals 0, because by Rolle's theorem, it said f prime to the x equals 0. That means 0 equal here, fx cubed minus 4x. Now, how are we gonna solve this one? How are we gonna solve this one? 0 equal what? 0 equal what?
4x in
The
parentheses.
common is 4x, and the left is what? X squared minus.
4.
That means 0 equal 4x, and 0 equal x squared minus 1. That means here 0 is going to be equal x. So here is the first x value, which is satisfied, because it's between -2 and 2, between A and B. On the other side, we're gonna solve this one. That means 1 is going to be equal x squared. Take the square root. So how many x value we have here? 2 x values from this side, which is also between the open interval -2 and 2. And we have x equals 0 between -2 and 2. So that's it. How many x values we have? 3 x values. And check the 3 x values between -2 and 2. That's it.